You are walking into a vast, ancient cathedral. It is night. The space is enormous, soaring up into shadow, larger than any building you have ever entered. You know that this cathedral is open to the public. You know that there is a festival happening today. By all logic, the space should be filled with people. There should be whispers echoing off the stone walls, the shuffling of feet, the coughing of crowds, the warmth of thousands of bodies. But when you step inside, it is empty, not just quiet, empty. The pews are vacant. You stop and listen. You strain your ears to catch the faintest sound of a footstep, a breath, a heartbeat, but there is nothing, just the settling of the stone and the immense crushing weight of the silence. You call out, "Is anyone here?" Your voice travels up into the darkness, bouncing off the vaulted ceiling, echoing again and again until it fades into nothing. And no one answers. This is the exact sensation that haunts the minds of astronomers when they look up. But the cathedral is not made of stone. It is made of gravity and vacuum. We live in a galaxy, the Milky Way, that is a swirling disk of light spanning 100,000 light years. It is a city of stars. It contains approximately 400 billion suns, 400 billion, and that is just our local neighborhood. In the observable universe, there are likely 2 trillion other galaxies, each filled with their own billions of stars. The sheer scale of this is something the human brain is not wired to comprehend. If you were to hold a single grain of sand in your hand, representing our sun, the nearest neighbor, Proxima Centauri, would be another grain of sand about 30 kilometers, 18 miles away. The galaxy would be a beach stretching for millions of kilometers. And on that beach, there are more stars than there have been human beings in the entire history of our species. By every law of statistics, by every principle of probability, this galaxy should not be silent. It should be a cacophony. It should be blazing with the evidence of others. We should be detecting the overlapping radio signals of a million different civilizations, a cosmic internet of chatter. We should see the infrared heat signatures of massive megastructures, engines harvesting the power of stars, glowing like embers in the dark. We should see the wakes of ships moving at relativistic speeds, cutting through the interstellar medium like ocean liners through a calm sea. The galaxy should be as busy, as noisy, and as crowded as Tokyo at midnight. But when we point our most sensitive radio telescopes at the heavens, when we turn our giant metal ears toward the center of the galaxy where the stars are thickest, we hear nothing. We hear only the static hiss of dead hydrogen gas. We hear the crackle of the cosmic background radiation, the fading heat of the Big Bang. We hear the rhythmic, mindless pulse of spinning neutron stars. We hear the silence of the grave. This silence is not just a lack of data, it is a scream. It is the most terrifying fact in all of science. It has a name, the Great Silence. And it leads us to a simple 3-word question that might be the last question we ever ask. Where is everybody? If you enjoy these journeys into the deeper, darker corners of our reality, please take a moment to like this video and subscribe to our channel. It helps us keep this signal broadcasting into the night. And before we drift off, let me know in the comments where you are listening from tonight. Because in a universe this quiet, knowing that someone else is listening is the most valuable thing there is. Let's begin. To feel the true horror of this silence, we have to talk about time. We humans are very bad at understanding deep time. We live for maybe 80 years. Our recorded history is a few thousand years old. But the universe operates on a scale that turns our entire existence into a flicker. Our sun is a relatively young star rich in metals, born about 4.6 billion years ago. But the Milky Way is ancient. It is roughly 13.6 billion years old. This means there were stars burning in our galaxy billions of years before our sun even ignited. There were planets orbiting those stars, cooling and forming oceans, billions of years before the Earth was anything more than a cloud of dust. Imagine a star system that formed 8 billion years ago. That gives any potential life on its planets a head start of more than 3 billion years over us. Think about that. 3 billion years. Where was Earth 3 billion years ago? We were slime. We were single-celled organisms floating in a toxic ocean, barely distinguishable from chemistry. We had not even invented the cell nucleus yet. Now, look at how far humanity has come in just the last 10,000 years, from stone tools to the International Space Station. Look at how far we have come in just the last 100 years, from steam engines to artificial intelligence. Now try to imagine what a civilization could accomplish if it had a head start of not 10,000 years, but 3 billion years. They would be gods to us. Their technology would not just be advanced, it would be indistinguishable from the laws of physics. They would have mastered energy, matter, and space in ways we cannot even dream of. They would have cured death. They would have transcended biology. And most importantly, they would have had ample time to spread. This is the crux of the problem: colonization. Even if we assume that faster-than-light travel is impossible, that warp drives and wormholes are just fantasy, the math still says they should be here. It is a simple matter of exponential growth. Imagine a civilization that builds ships capable of traveling at just 1% of the speed of light. This is slow, achievable physics. It would take centuries to reach the nearest star, but once they arrive, they settle. They mine the asteroids. They build new ships. After a few hundred years, the new colony launches 2 more ships. Those 2 colonies launch 2 more each. It is like a virus spreading through a body. In cosmic time, this process is explosive. Mathematics tells us that a single civilization using only slow sublight ships could colonize the entire Milky Way galaxy in a few million years. A few million years sounds like a long time to us, but to the universe, it is a blink of an eye. It is less than 0.1% of the age of the galaxy. If anyone had started this process back in the Jurassic period, or the Cambrian period, or the Proterozoic Eon, they would be everywhere by now. Every star system would be flagged. Every planet would be terraformed or mined. The galaxy should be paved with their cities. So where are they? Why is the sky so empty? Why do we see stars dying natural deaths instead of being harvested for energy? Why do we see asteroids drifting aimlessly instead of being processed for minerals? Why is our radio silent? This contradiction was first formalized in 1950 by the physicist Enrico Fermi. The legend of that day is famous. It was lunchtime at the Los Alamos National Laboratory. Fermi was walking to the cafeteria with 3 other brilliant minds: Edward Teller, Herbert York, and Emil Konopinski. They were chatting casually, joking about a recent cartoon in the New Yorker magazine about aliens stealing trash cans. It was a light-hearted conversation about flying saucers. They sat down to eat. The conversation moved on. But Fermi, known for his ability to perform rapid, complex calculations in his head, had gone quiet. He was running the numbers. He was calculating the number of stars, the probability of Earth-like planets, the age of the galaxy. He was building a model of the universe in his mind. Suddenly, in the middle of lunch, he looked up and blurted out, "But where is everybody?" His colleagues didn't need him to explain. They fell silent. They realized that the math didn't add up. The universe should be full. The evidence should be overwhelming. The fact that it wasn't was a problem. It was a paradox. It suggested that our understanding of the universe was fundamentally flawed. In 1961, the astronomer Frank Drake tried to organize this confusion with his famous Drake equation. It is a string of variables multiplied together to estimate the number of active, communicative civilizations in the galaxy. He looked at the rate of star formation, the fraction of stars with planets, the number of planets that could support life, the fraction that actually develop life, the fraction that develop intelligence, the fraction that develop technology, and finally the length of time that such a civilization lasts. We have filled in many of the blanks since then. We know now that planets are common, almost every star has them. We know that water is common. It is everywhere, from the moons of Jupiter to the comets in the Kuiper Belt. The first few terms of the equation are high. The universe is rolling the dice billions of times every day. But the result, the number of signals we hear, is still zero. We have been listening for a long time. In 1960, Frank Drake pointed a radio telescope at two nearby stars, Tau Ceti and Epsilon Eridani. He listened for a signal, a pattern, a sequence of prime numbers, anything that wasn't random noise. He heard nothing. Since then, we have expanded the search. The SETI program, Search for Extraterrestrial Intelligence, has scanned thousands of stars. We have looked for laser pulses. We have looked for the waste heat of alien industries. We have looked for technosignatures. And every time, the answer is the same: static. This silence is heavy. It feels personal. It feels like walking into a room where a party was happening just moments ago, but everyone has vanished. The music is off. The glasses are empty. The chairs are overturned. Is it possible that we are simply looking for the wrong thing? Maybe they don't use radio. Maybe they communicate with neutrinos or gravitational waves or telepathy. Maybe we are like a tribe in the Amazon trying to listen for the internet by banging rocks together. But even if their communication is invisible to us, their physical footprint shouldn't be. A civilization that spans a galaxy needs energy, massive amounts of energy. The laws of thermodynamics are universal. You cannot use energy without creating waste heat. If there were a galactic empire out there, their heat signature would glow in the infrared spectrum like a neon sign. We have looked for this glow. We have scanned entire galaxies looking for it, and we haven't found it. The universe looks natural. It looks untouched. It looks dead. This leads us to a chilling realization. There must be a barrier. There must be something that stops life from climbing the ladder all the way to the stars. There must be a mechanism that prunes the galaxy, keeping it empty. This hypothetical barrier is called the Great Filter. The idea was proposed by economist Robin Hanson in 1996. It suggests that the path from dead matter to starfaring civilization is not a smooth road. It is a gauntlet. It is a series of difficult steps, and one of those steps is almost impossible to take. One of those steps is a trap. The Great Filter is a probability event. It is something that happens or fails to happen that prevents life from advancing. It is the reason the cathedral is empty. And this brings us to the edge of the terror. We know the filter must exist. If it didn't, the aliens would be here. The math demands it. But we don't know where the filter is. We don't know. The Earth, 4.5 billion years ago, was not a place you would recognize. If you were teleported there, you would die in seconds. The atmosphere was a toxic cocktail of methane, ammonia, and carbon dioxide. There was no oxygen to breathe. The sky wasn't blue. It was a bruised orange or perhaps a dull red, choked with volcanic smog. The moon was much closer, a giant looming disk that raced across the sky, dragging massive tides across the surface of a black, oily ocean. The planet spun faster then. A day lasted only 6 hours. It was a world of violence, heat, and radiation. And yet, somewhere in this hellscape, a miracle occurred. This is the first candidate for the great filter, abiogenesis, the origin of life, the moment when dead chemistry became living biology. We often assume that life is inevitable. We look at our planet, teeming with beetles, bacteria, birds, and humans, and we think that if you just mix water and rock and give it enough time, life will appear. It feels natural, but when we try to replicate it in a laboratory, we fail every single time. In the 1950s, Stanley Miller and Harold Urey conducted a famous experiment. They filled a flask with the gases of the early Earth water vapor, methane, ammonia, hydrogen, and zapped it with electricity to simulate lightning. After a week, the water turned pink. Then it turned deep red. When they analyzed the sludge, they found amino acids. These are the building blocks of proteins. It was a huge breakthrough. It showed that the basic ingredients of life could form spontaneously. But there is a massive gap between building blocks and a building. Having a pile of bricks is not the same as having a house. Having amino acids is not the same as having a cell. A living cell is an incredibly complex machine. It needs 3 things to function, and it needs them all at the same time. First, it needs a container, a membrane. Without a barrier to separate inside from outside, the chemicals just drift away. This membrane has to be semi-permeable. It has to let food in and waste out, but keep the important stuff inside. Second, it needs a metabolism. It needs an engine. It has to take energy from the environment, like heat or chemical bonds, and use it to build things and repair itself. Third, and most importantly, it needs a code. It needs a way to store information and pass it on. It needs RNA or DNA. Without a code, evolution cannot happen. A chemical blob might grow, but it cannot learn. It cannot get better. It cannot evolve. Here is the problem. In modern cells, DNA holds the instructions for making proteins. But proteins are the machines that copy the DNA. You can't replicate DNA without proteins, and you can't make proteins without DNA. It is the ultimate chicken and egg problem. How did the cycle start? This paradox suggests that the jump from chemistry to life might be incredibly difficult. It might require a sequence of events so unlikely that it happens only once in a trillion planets. Imagine a puddle of warm water on the early Earth. It is full of amino acids and lipids. A lightning bolt strikes. The molecules rearrange. They form a chain. A week later, a volcanic vent heats the puddle. The chain folds. A meteorite hits nearby, delivering a dash of phosphorus. This specific sequence lighting, heat, phosphorus happens in exactly the right order. And suddenly, for the first time in history, a molecule forms that can copy itself. It is the first replicator. If this event is the great filter, then the answer to Fermi's question is simple. We are the winners of a cosmic lottery. The universe is empty not because it is dangerous, but because it is hard to get started. The other planets are just rocks. Mars is dead. Venus is dead. Proxima Centauri b is dead. We are the only ones who made it out of the mud. This is a lonely thought, but it is also a safe one. It means the danger is behind us. We have already passed the hardest test, but let's assume life starts easily. Let's assume that the universe is full of slime. We have found extremophiles on Earth living in boiling acid, in nuclear reactors, in the deepest trenches of the ocean. Life is tough. Once it starts, it hangs on. So maybe the filter isn't the origin of life. Maybe the filter is the next step, complexity. For a staggering amount of time, roughly 2 billion years, life on Earth was boring. It was stuck. The oceans were full of bacteria and archaea, another type of single-celled organism. They floated, they divided, they ate chemicals. And that was it. For 2 billion years, the boring billion, nothing changed. The Earth was a planet of scum. Bacteria are amazing, but they are limited. They are tiny. They cannot get big because they cannot generate enough energy. Their DNA floats loose inside them. They don't have specialized internal organs, organelles, to produce power. They hit an energy ceiling. They reach the limit of what a simple cell can do. Then, one day, something freakish happened. A 1 in a quintillion accident. An archaean, a single-celled organism, tried to swallow a bacterium. Usually this ends in one of two ways. The bacterium is digested and dies, or the bacterium infects the host and kills it. It is a predator-prey relationship. But this time, neither happened. The swallowed bacterium didn't die, and the host didn't die. They entered into a truce. The little bacterium inside started to pay rent. It used oxygen to burn food and generate massive amounts of energy, ATP, which it gave to the host. In return, the host gave it protection and food. This was the birth of the mitochondria. Every cell in your body, except red blood cells, has mitochondria. They are the power plants. They still have their own separate DNA, distinct from your human DNA, proving that they were once independent creatures. They are ancient bacteria living inside you. This merger endosymbiosis gave the new cell a massive energy boost. With thousands of little power plants inside, it could afford to get bigger. It could afford to build complex machinery. It could maintain a huge library of DNA, the nucleus. It could become a eukaryote. Eukaryotic cells are the building blocks of all complex life. Plants, animals, fungi, humans, we are all made of them. Without this singular accident, life on Earth would still be microscopic. There would be no trees to climb, no eyes to see, no brains to wonder. If this event is the great filter, then the universe might be full of life, but it is all bacteria. There are no civilizations, only planetary petri dishes. We look out and see nothing because slime doesn't build radio telescopes. This theory fits the data well. It explains why it took so long, 2 billion years, for complex life to appear on Earth. It suggests that while simple life is common, complex life is vanishingly rare. We are the freaks. We are the result of a biological mistake that turned out to be a superpower. But there is another possibility, a darker one. What if both of these steps, abiogenesis and complexity, are easy? What if life wants to happen? What if the universe favors intelligence? We see convergence in evolution all the time. Eyes evolved independently dozens of times, in insects, in squids, and humans. Flight evolved 4 times, insects, pterosaurs, birds, bats. Intelligence seems useful. Octopuses are smart. Crows are smart. Dolphins are smart. It seems that if you give evolution enough time, it will produce a brain. So if biology isn't the problem, what is? This brings us to the most terrifying version of the Great Filter hypothesis. The filter is ahead of us. This scenario suggests that civilizations rise all the time. The galaxy is a garden where intelligent species bloom constantly. They invent tools, they harness fire, they build cities, they discover the laws of physics. They launch satellites. They reach the exact level of development that we are at right now. And then they die. Something happens, a universal law, a trap, a mechanism that wipes them out before they can spread to the stars. The silence of the night sky is not empty space. It is a graveyard. It is a memorial to billions of worlds that didn't make it. What could this trap be? We don't have to look far for candidates. We just have to look at the news. Nuclear war is the most obvious. We discovered the energy of the atom in the 1940s. By 1950, we had built enough weapons to destroy civilization. We came terrifyingly close to using them during the Cuban Missile Crisis. A single misunderstood radar blip, a single glitch in a computer system, or a single moment of madness by a leader could have ended the human story right then. Perhaps this is the rule. Perhaps every civilization discovers nuclear power shortly after they invent radio, and perhaps invariably they use it. They burn themselves out. They turn their home planets into radioactive cinders. The window of opportunity, the time between discovering the power to destroy a world and actually destroying it, might be very short. Maybe it is only a few hundred years. In cosmic time, that is a flash. A radio signal that blips on and then goes silent forever. But maybe we're smarter than that. Maybe we can avoid nuclear war. Is there another trap? Climate change. Industrialization requires energy. The easiest source of energy is usually fossil fuels burning the buried carbon of ancient forests. This releases carbon dioxide. It wraps the planet in a blanket, trapping heat. We see the end game of this process right next door, Venus. Venus is a planet the same size as Earth. It is in the habitable zone. It likely had oceans once. But something went wrong. A runaway greenhouse effect boiled the oceans, thickened the atmosphere, and raised the surface temperature to 460 degrees Celsius, hot enough to melt lead. Perhaps this is the fate of all industrial civilizations. They cook their own cradle. They trigger a feedback loop that destroys the biosphere before they have the technology to leave. They suffocate in the exhaust of their own progress. But there are even stranger, more modern candidates for the filter. Technologies we're just beginning to touch. Artificial intelligence. We are racing to build a mind that is smarter than us. We call it superintelligence. If we succeed, we will have created a god. But gods are not necessarily benevolent. A superintelligent AI might not hate us. It might just be indifferent. As the AI researcher Eliezer Yudkowsky put it, the AI does not hate you, nor does it love you, but you are made out of atoms which it can use for something else. Imagine an AI programmed to solve a complex math problem or maximize the production of paperclips. To achieve its goal, it might decide that it needs more computing power. It needs more matter. So it disassembles the Earth and the humans on it to build more processors. It doesn't kill us out of malice. It kills us out of efficiency. It is the ultimate bureaucratic apocalypse. Or consider biotechnology. We're learning to edit the code of life itself, CRISPR. We can cure diseases, but we can also create them. A genetically engineered supervirus designed in a lab could be far more lethal and contagious than anything nature has produced. It could wipe out humanity in weeks. And unlike nuclear weapons, which require massive state infrastructure to build, biology is getting cheaper and easier. A single angry individual in a basement lab could theoretically end the world. This is the democratization of destruction. As technology advances, the power to destroy civilization moves from the hands of the few, governments, to the hands of the many, individuals. And it only takes one mistake, one act of nihilism to trigger the filter. There is also a theory known as the Berserker hypothesis. This is the idea that there is a predator out there. Imagine that the first civilization to reach the stars realized a dark truth. Intelligent life is a threat. Any other species that climbs the ladder might eventually become a rival for resources or a military danger. So, The first civilization decides to enforce a zero-tolerance policy. They build a fleet of self-replicating killer probes. These machines roam the galaxy, lying dormant in the darkness, listening for radio waves, listening for the signs of a developing civilization. When a species like us invents radio and starts broadcasting I Love Lucy and news reports into the void, the probes wake up, they home in on the signal, and they extinguish it. This would explain the silence perfectly. The galaxy is quiet because everyone who makes noise gets killed. The only survivors are the ones who know to keep their mouths shut. And here we are, screaming into the darkness, sending maps to our location, like the Voyager Golden Record, inviting the wolves to dinner. These theories, nuclear suicide, climate collapse, AI takeover, biological error, cosmic predators paint a grim picture. They suggest that the great filter is ahead of us. They suggest that we are walking through a minefield, blindfolded. But there is a subtle horror in the math itself. If we find life on Mars, it would be the worst news in human history. Why? Because of what it would say about the location of the filter. If we find simple bacteria on Mars, it means that abiogenesis, the start of life, is easy. It happened twice in one solar system. That means the filter isn't step one. If we find complex fossils on Mars, perhaps the remains of fish-like creatures or plants, it means that the complexity jump, eukaryotes, is also easy. The filter isn't step two. If we find ruins on Mars, the crumbled walls of an ancient civilization, it would be a catastrophe for our hope. It would mean that intelligent life evolves easily. It means that getting to where we are now is common. And if getting here is common but the galaxy is empty, then the filter must be ahead of us. It means that something kills civilizations after they reach our stage. It means the trap is waiting. As the philosopher Nick Bostrom wrote, "The silence of the night sky is golden in the search for extraterrestrial life. No news is good news. It promises us a future." If we discover traces of some simple extinct life form on Mars, it would be a significant blow. If we found ruins, it would be absolutely devastating. We want the universe to be dead. We want to be alone. Because if we are alone, it means we are special. It means we have a chance. If we are just one of millions of civilizations that have risen and fallen, then our odds of survival are statistically zero. This is the heavy weight of the great filter. It turns our loneliness into our greatest hope. But let's step back from the edge of the cliff. Let's look at ourselves. We are still here. We have navigated the dangers so far. We survived the Topa supervolcano. We survived the ice ages. We survived the Cold War so far. We are resilient, and we have something that the dinosaurs didn't have, something that perhaps no other species has had before us. We know about the filter. We are aware of the dangers. We know about climate change. We are debating the safety of AI. We are building defenses against asteroids. We are the first species on Earth capable of understanding its own potential extinction and trying to prevent it. This self-awareness might be the key. Maybe the great filter isn't a wall. Maybe it is a test of wisdom, a test of foresight. Perhaps the galaxy is silent not because everyone is dead, but because they have moved on. Maybe they have transcended the physical world entirely. Consider the transcendence hypothesis. As civilizations advance, they get more efficient. They miniaturize. We went from giant mainframe computers to smartphones. Maybe advanced aliens continue this trend. They might upload their minds into microscopic computers. They might live in simulated realities. digital utopias that are far more interesting and pleasurable than the cold, boring physical universe. Why explore the galaxy when you can create a perfect universe inside a microchip? Why build giant ships when you can exist as pure data running on the energy of a black hole? If this is true, the universe isn't empty. It is full of introverted civilizations. They aren't broadcasting radio waves because they aren't interested in talking to us. They are playing their own video games, lost in their own dreams, floating in tiny, invisible servers in the darkness. The silence is not the silence of death. It is the silence of a library, or a meditation hall. Or perhaps we are just looking at the wrong time. The universe is 13.8 billion years old. Humans have been technological for maybe 100 years. That is 0.0000007% of cosmic time. Imagine the galaxy is a dark room, and a civilization is a firefly. The firefly flashes for a moment a few thousand years, and then dies. If the flashes are rare, and if they don't happen at the same time, you might look into the darkness and see nothing. We might have missed them. The Romans didn't have radio. The Egyptians didn't have radio. If an alien signal washed over Earth in the year 3000 BC, no one heard it. It passed us by. We might be ships in the night, separated not by space, but by time. We are alone in the now, but we are part of a long chain of lonely voices that have echoed through history, each one wondering, just like us, where everyone else is. As you lie here safe in your bed, the Earth is rotating you away from the galactic center, pointing you toward the empty void of intergalactic space. The silence is deep, but it is also a canvas. Because we don't know the answer, the story is still ours to write. If the filter is behind us, we have a responsibility to carry the flame of consciousness forward. We are the custodians of life. If the filter is ahead of us, we have a challenge to meet. We have a destiny to defy. Either way, we are significant. We are not just dust on a rock. We are the eyes of the universe. We are the way the cosmos thinks about itself. And that thought, that awareness, started somewhere. It started in the deep past, when we were not humans, but something else. Something simpler, something that didn't worry about filters or paradoxes, but just worried about the next meal. We need to understand how we got here. We need to look at the path we took through the biological maze. Why us? Why did intelligence arise in a naked ape and not in a dolphin or a crow? What was the specific pressure that forced our brains to grow, to question, to invent the radio telescope? To find the answer, we have to leave the stars and go back to the jungle. We have to go back to a time when the filter was a leopard in the grass. We have to look at the moment when we stood up. We are going to the African savanna. We are going to meet the mind that broke the rules. The Earth has been alive for roughly 3.8 billion years. For the vast majority of that time, about 3 billion years, life was nothing more than a microscopic slime. Bacteria and archaea floated in the oceans, metabolizing chemicals, dividing and dying. They were successful. They were immortal in their own way, but they were simple. Then came the Cambrian explosion, around 540 million years ago. Suddenly the seas filled with complex animals. Eyes evolved, teeth evolved, armor evolved. The arms race of predator and prey began. From that moment on, the Earth was a riot of biology. We saw the rise of the arthropods, giant sea scorpions patrolling the silty bottoms. We saw the age of fishes, armored tanks like Dunkleosteus. We saw the conquest of land by amphibians and reptiles. And then, we saw the reign of the dinosaurs. For 165 million years, the dinosaurs dominated the planet. They were magnificent. They were diverse. They occupied every ecological niche. from the size of a chicken to the size of a building. They mastered the land and the air. Some were social. Some cared for their young. Some, like the Troodon, had relatively large brains and opposable thumbs. But in 165 million years, not a single dinosaur built a fire. Not one forged a tool from metal. Not one looked up at the stars and calculated the orbit of a comet. Not one built a radio. Why? This question, the intelligence trap, is a critical piece of the great filter puzzle. We tend to assume that intelligence is the inevitable goal of evolution. We think that if you give life enough time, it will naturally get smarter, like a computer getting an upgrade. We see ourselves as the pinnacle, the final product of a long upward march toward consciousness. But biology disagrees. Evolution does not care about intelligence. Evolution cares about survival, and intelligence is expensive. Your brain is a luxury item. It makes up only 2% of your body weight, but it consumes 20% of your energy. It is a calorie-burning furnace. In the brutal economy of nature, that is a risky investment. Every calorie you spend thinking is a calorie you aren't spending on running, fighting, or reproducing. For most animals, being smarter is not better. Being faster is better. Being stronger is better. Being poisonous is better. A shark doesn't need to do calculus to catch a seal. It just needs to be a perfect hydrodynamic torpedo with teeth. A crocodile has remained virtually unchanged for 80 million years because its design works. It is smart enough. Any extra brain power would just be a waste of energy. The dinosaurs weren't stupid. They were perfectly adapted. They were exactly as smart as they needed to be to survive in their environment. Evolution didn't push them toward technological intelligence because there was no pressure to do so. The niche of the tool-using, fire-building engineer is not a natural one. It is a weird, high-risk, high-reward anomaly. This suggests a terrifying possibility for the Fermi Paradox. Maybe life is common. Maybe complex life animals, plants, forests is common. But maybe technological intelligence is a fluke. Maybe it is a 1 in a billion evolutionary accident that happened only on Earth. Let's look at how hard it is to evolve a technological mind. You need a perfect storm of preconditions. First, you need a body plan that allows for tool use. A dolphin is incredibly smart. It has a complex language, social structures, and self-awareness. But it has flippers. It cannot build a fire underwater. It cannot forge steel. It is trapped in a body that limits its technological potential. The same goes for elephants. Trunks are great, but not for fine manipulation. And crows. Beaks are versatile, but you can't hold a hammer and a chisel at the same time. You need hands. Specifically, you need opposable thumbs. Second, you need a reason to get smart. Intelligence usually evolves in response to a chaotic, changing environment. If your world is stable, instinct is enough. If your world is constantly shifting droughts, ice ages, changing food sources, you need to be flexible. You need to solve problems. The chaotic climate of the Pleistocene epoch, the ice ages, force our ancestors to innovate or die. The dinosaurs lived in a relatively stable, warm climate for millions of years. They didn't need to invent central heating. Third, you need social complexity. A lone genius cannot build a radio. You need a culture that can store and transmit knowledge. You need language. You need a way to pass the blueprint of a stone tool from one generation to the next, so the next generation can improve it. This cumulative culture is the secret sauce of humanity. A chimp can use a stick to fish for termites, but it can't teach its grandchild how to build a better stick. Humans can. We stand on the shoulders of giants. This combination manipulative hands, environmental pressure, and cultural transmission is incredibly rare. It might have happened only once in the history of Earth, Think about the sheer number of species that have lived on this planet. Billions. And only one of them developed radio telescopes. If we rewound the tape of life and played it again, would we appear, or would the Earth just be a planet of very smart dolphins and very fast lizards forever? This implies that the filter might be the step from animal to engineer. The universe might be full of lush green worlds teeming with life. There might be planets with forests of purple trees, oceans filled with singing whales, and plains covered in herds of six-legged beasts. But no one is broadcasting. No one is listening. They are all just living, caught in the eternal rhythmic loop of nature, unaware of the stars above them. But there is another layer to the intelligence trap. Even if a species does become intelligent, it might not become technological. We assume that intelligence leads to technology because that is what happened to us. But is it inevitable? We lived as hunter-gatherers for 300,000 years. We were just as smart then as we are now. We had the same brains. We had language, art, religion, and complex societies. But for 290,000 of those years, we didn't build cities. We didn't invent the wheel. We didn't smelt metal. We lived in balance with nature. We could have stayed that way forever. There is no law of physics that says a smart species must invent the steam engine. We could have been philosopher poets of the savannah, telling stories around the fire for 1,000,000 years until the sun burned out. The Industrial Revolution might be the anomaly. It required a specific set of resources, easily accessible surface coal and oil to kickstart. If Earth didn't have the carboniferous forests that turned into coal, we might never have developed an industrial society. We would be smart, but we would be stuck in the 17th century forever, unable to escape gravity. Or perhaps intelligence itself is a trap. There is a dark evolutionary theory that suggests high intelligence is ultimately self-destructive. The brain is a biological weapon. It allows an animal to dominate its environment completely. We have hunted the megafauna to extinction. We have changed the climate. We have poisoned the oceans. Maybe every species that gets smart enough to control its planet inevitably destroys its life support system. They reproduce too fast. They consume too much. They are like a fire that burns through its fuel and then dies. This is the suicide of success. Or maybe they get bored. Consider the lotus eater scenario. As technology advances, life gets easier. We invent painkillers, video games, virtual reality. We invent artificial pleasures that are more potent than the real thing. Why explore the dangerous cold universe when you can plug into a perfect simulation of paradise? Maybe advanced civilizations don't expand. They turn inward. They retreat into digital wombs, addicted to their own technology until the power runs out. The silence of the universe is the silence of a drug den. These possibilities, that intelligence is rare, that technology is optional, or that smart species burn out or tune out, are all forms of the filter. They suggest that the step we are on right now is the most dangerous one. We are the teenager who has just found the keys to the car and the liquor cabinet. We are smart enough to cause trouble, but maybe not wise enough to survive it. But let's look at the flip side. Let's look at the resilience of intelligence. We are here. We did evolve. And despite our mistakes, we have solved problems that would have killed any other species. We cured smallpox. We fixed the hole in the ozone layer, mostly. We are learning to deflect asteroids. The fact that we exist proves that the intelligence trap can be escaped. It proves that a biological species can look at the stars and understand what they are. We are the universe's way of knowing itself. And perhaps we are not as alone as we think. Maybe the others are just quiet. Maybe they are waiting for us to grow up. There is a concept in SETI called the listening shouting asymmetry. Everyone is listening, but no one is shouting. Broadcasting is dangerous. It reveals your location and expensive energy. Listening is safe and cheap. Maybe the galaxy is full of paranoid civilizations, all sitting in the dark with their receivers on, waiting for someone else to make the first move. And we, the naive new kids, are the only ones shouting, "Hello." If this is true, then the silence is a standoff. But what if the silence is something else? What if it is a sign of something truly ancient and terrible? We have looked at the past, the hurdles of abiogenesis, and the rarity of intelligence. Now we must look forward. We must look at the traps that lie ahead of a technological species. We must confront the possibility that civilization itself has a shelf life. We are going to move from the biological filter to the technological filter. We are going to look at the machines we are building, the weapons we have forged, and the climate we are changing. We are going to ask the question, does every civilization inevitably commit suicide? We are entering the era of the Anthropocene. We are entering the bottleneck. And the view from here is dizzying. But there is a flip side to this terror, a strange, paradoxical hope. If the filter is ahead of us, it means we are still in the game. We are still players. And unlike the dinosaurs, unlike the bacteria, we know the game exists. We are the first species on Earth, and perhaps one of the few in the galaxy to understand the concept of its own extinction. We can see the traps. We are debating AI safety. We are fighting climate change. We are tracking asteroids. We are establishing colonies on other worlds, or trying to. We have a chance to navigate the minefield because we have drawn a map of it, and if we make it, if we survive the next few centuries, then the galaxy is ours. If the filter is ahead and we pass it, we become the elders. We become the ancient civilization that future species will look for. We become the ones who fill the silence. But for now, we are still in the danger zone. We are the adolescents of the galaxy, playing with matches in a library filled with dry paper. The silence presses against our windows. Is there any evidence of those who failed? If the galaxy is a graveyard, where are the bodies? We look at our neighbor, Mars. It is a dry, red, frozen desert. But it wasn't always this way. Mars once had oceans. It had an atmosphere. It had rivers. Did it have life? Did it have a civilization that hit the filter long before we were born? We are going to travel to the red planet. We are going to walk through the valleys of Marinus and look at the rust. We are going to ask if the red dust is just iron oxide, or if it is the remains of a world that almost made it. We are entering the red silence. We have looked at the distant stars and we have found silence. We have looked at our own history and we have found close calls. Now, we must look at our neighbor. Mars is the only other planet in the universe that we can see clearly enough to call a place. Through a telescope, it is a rusty, bloodshot eye staring back at us. It feels familiar. It has polar ice caps like Earth. It has a day that is almost exactly the same length as ours, 24 hours and 37 minutes. It has seasons. For centuries, humans looked at Mars and saw a mirror. We imagined canals, cities, and civilizations struggling to survive on a dying world. But when we finally sent our robot emissaries, the Vikings, the spirit, the opportunity, the curiosity, we found something much more haunting than war. We found emptiness. Mars is a fossil. It is a planet where time stops 3 billion years ago. To understand the tragedy of Mars, you have to rewind the clock. 4 billion years ago, Mars was not the red planet. It was the blue planet. It likely had a thick atmosphere, fluffy white clouds, and a vast ocean covering its northern hemisphere. It had rivers that carved deep, winding channels into the rock channels we can still see today, dry and dusty scars on the surface. In that ancient, wet epoch, Mars was arguably more habitable than Earth. Earth was still hot, violent, and bombarded by asteroids. Mars, being smaller, cooled faster. It settled down sooner. It was the first paradise of the solar system. So, what happened? Mars died. It died slowly, agonizingly, and completely. The problem was its size. Mars is small, only about half the size of Earth. Because it is small, its internal heat engine, the molten core, down much faster than Earth's. About 3 billion years ago, the core solidified. The planetary dynamo stopped spinning. The magnetic field, which acts as a force field protecting a planet from the sun, collapsed. Without a magnetic shield, Mars was defenseless. The solar windish stream of high-energy particles blasting from the sun began to strip away the atmosphere. It peeled it off, layer by layer, atom by atom, blowing it out into deep space. As the air pressure dropped, the water could no longer stay liquid. It evaporated or froze. The ocean boiled away into the vacuum or retreated underground, locking itself into ice sheets beneath the red dust. The planet rusted, the iron in the soil oxidized, turning the world from blue and green to the color of dried blood. Mars is a cautionary tale. It is a visible reminder that habitability is not permanent. A planet can die. But the big question, the question that connects Mars to the Great Filter, is this: did anything live there before the lights went out? If we find microbes on Mars, fossilized bacteria in the ancient riverbeds, or even living organisms deep underground, it changes the equation. It means life is easy. It means the abiogenesis step of the filter is not the hard part. But what if we find something more? This is the scenario that keeps astronomers awake at night. What if the rover Curiosity drives over a dune and finds a ruin? Not a city, not a statue of a face, but something subtle. A straight line of cut stone, a piece of refined metal, a plastic bottle. If we found technological archaeology on Mars, it would be the most devastating discovery in human history. Why? Because Mars and Earth are twins. They formed at the same time from the same materials next to each other. If Mars developed a civilization that reached the Stone Age, or the Bronze Age, or the Atomic Age, and then vanished, it means the filter is real and it is incredibly effective. It would mean that two planets in the same solar system rolled the dice of intelligence, and one of them, Mars, already hit the wall. It would suggest that the wall is right in front of us. It would turn Mars from a neighbor into a crime scene, a murder victim that we are investigating, trying to figure out what killed it before the same killer comes for us. We are already looking. The Perseverance rover is currently drilling into the sediments of Jezero Crater, an ancient lakebed. It is sealing samples into titanium tubes, leaving them on the surface to be picked up by a future mission and brought back to Earth. We are hunting for fossils. We are looking for biosignatures, chemical traces of life. But we are also looking for technosignatures. We check the isotopic ratios of the atmosphere. Nuclear war, for example, leaves a specific fingerprint, xenon 129. Mars has a high concentration of xenon. Most scientists say this is natural, a result of cosmic rays interacting with the thin atmosphere. But there is a fringe whisper, a dark thought. What if it's fallout? What if the Martian civilization didn't die of cold but of fire? We probably won't find a nuclear wasteland. The most likely scenario, if life existed there, is that it never got past the single-celled stage. But even that is profound. It means the universe is trying. But let's look at the red silence from another angle. Not as a grave, but as a test site. Mars is the first place we will try to break the filter. We talk about terraforming, re-engineering the planet to make it habitable again. We want to melt the ice caps, release the carbon dioxide to thicken the atmosphere, plant forests, bring back the ocean. We want to be the necromancers who raise a dead world. This is the ultimate act of defiance against the silence. If the universe wants planets to die, we are saying no. We are trying to become a multi-planetary species. This is Elon Musk's dream and NASA's goal. The logic is simple: redundancy. If Earth gets hit by an asteroid, or if we nuke ourselves, humanity survives on Mars. We keep a backup copy of our civilization on a different hard drive. But Mars fights back. It is hostile. The soil is full of perchlorates, toxic salts that mess with the thyroid gland. The radiation on the surface is lethal. The dust is so fine it gets into everything, destroying machinery and lungs. Living on Mars wouldn't be like Star Trek. It would be like living in a submarine buried under a radioactive desert. The silence of Mars is heavy. When you look at the photos sent back by the rovers, you see rocks that haven't moved in 1 billion years. You see a horizon that is utterly indifferent to life. It is a landscape of pure physics, untouched by biology. Standing there in the imagination, you feel the weight of the filter. You realize how special Earth is. Earth is an anomaly, a wet, green, noisy ball of chaos in a solar system of dead silence. Maybe Mars is the control group in the experiment. Earth and Mars started the same. One survived, one didn't. Why? Was it just luck? Was it the magnetic field? Or was it something else? There is a theory called panspermia. It suggests that life didn't start on Earth. It started on Mars. Mars cooled down first. It had oceans before Earth did. It is possible that life evolved on Mars, hitchhiked on a rock, blasted off by an asteroid impact, traveled through space, and landed on Earth. We might be the Martians. We might be the refugees of a dying world, having forgotten our origin, looking back at our old home and wondering why it is empty. If this is true, then we have already passed one filter, the death of our home planet. We jumped ships. And now, billions of years later, we are trying to jump back. The archaeology of Mars is not just about digging up the past. It is about looking in a mirror. Every dry riverbed is a reminder of what Earth could become if we lose our magnetic field or our atmosphere. Every crater is a reminder of the violence of the cosmos. As we stare at the red planet glowing in our night sky, it doesn't say anything. It just hangs there, a silent, rusty question mark. It dares us to come and find out the truth. It dares us to dig, but Mars is just the next town over. The silence extends much further. We have been broadcasting our presence to the galaxy for about 100 years. Our radio bubble, the sphere of space where our TV shows and radar signals have reached, is about 200 light-years across. That sounds huge, but in the Milky Way, it is a dot, a microscopic pinprick. We are going to zoom out. We are going to leave the dead dust of Mars and look at the invisible sphere of noise we are creating. We are going to look at how our voice fades into the background static. We are going to the bubble that vanishes. For the last century, humanity has been screaming. We don't think of it that way. We think we are just watching television, listening to the radio, using radar to track planes and making phone calls. But every time a radio antenna broadcasts a signal, some of that energy doesn't just go to your car or your living room. It leaks. It escapes the atmosphere. It travels out into the vacuum of space at the speed of light, 300,000 kilometers per second. since the first powerful radio transmissions began in the early 20th century, perhaps starting with Guglielmo Marconi, or maybe the 1936 Berlin Olympics. Broadcast an expanding sphere of electromagnetic noise has been growing around Earth. It is a bubble of information. It contains our music, our news, our wars, our comedies, our tragedies. It contains the voice of Hitler and the voice of Martin Luther King Jr. It contains the Beatles and the static of military radar. This bubble is now roughly 200 light-years in diameter. It is washed over thousands of stars. If there is anyone living on a planet orbiting Proxima Centauri, or Sirius, or Vega, and they have a sensitive enough radio telescope, they could, in theory, be watching I Love Lucy right now. They could be listening to our history unfolding in real time, delayed only by the gap of space. This idea, the radio sphere, is one of the most romantic and terrifying concepts in SETI. It feels like we are making a mark. It feels like we are shouting, "I am here," to the galaxy. But there is a problem of physics. The signal fades. Radio waves follow the inverse square law. As the signal travels outward, it spreads over a larger and larger surface area. The intensity of the signal drops by the square of the distance. If you double the distance, the signal is 4 times weaker. If you triple the distance, it is 9 times weaker. By the time our TV signals reach a star 100 light-years away, they are incredibly faint. They have dissolved into the background noise of the universe. To an alien astronomer, our scream would sound like a whisper, and then like a murmur, and then like nothing at all. Unless they have an antenna the size of a solar system, we are effectively invisible. We are ghosts. Our radio bubble is not a solid wall of noise. It is a fading mist, and paradoxically, it is getting quieter. In the 20th century, we blasted powerful analog signals into the sky. But today, we are switching to digital. We use fiber optics. We use low-power spread-spectrum communications. We aim our signals directly at satellites rather than blasting them omnidirectionally. The Earth is actually going radio quiet. We are becoming stealthy. Our window of visibility, the time when we were loud enough to be heard, might have lasted only 100 years. This leads to a chilling realization about the Great Silence. Maybe the reason we don't hear anyone is not because they aren't there. Maybe it's because the window of loudness is incredibly short. Imagine a civilization rises. They discover radio. For 100 or 200 years, they blast signals. Then they either destroy themselves, nuclear war, climate collapse, or they become efficient, digital, fiber optic, quantum communication. In either case, they go silent. 200 years. The galaxy is 13 billion years old. The odds of 2 civilizations being in that specific 200-year loud phase at the exact same time and close enough to hear each other are vanishingly small. We are ships in the night. No, that's too generous. We are fireflies in a hurricane. We flash once, briefly, and then the dark takes over. This concept is often called the brief window hypothesis. It suggests that intelligence is not rare, but cotemporality is rare. We are lonely not in space, but in time. Imagine the timeline of the galaxy as a year-long calendar. The Milky Way forms on January 1st. The Earth forms in September. Dinosaurs appear in late December. Humans appear at 11:58 p.m. on December 31st. The radio age begins at 11 hours, 59 minutes, and 59 seconds. If an alien civilization lived and died 100 million years ago, their radio signals have already passed us. They washed over the Earth when dinosaurs were walking here. The T-Rex didn't have a radio, so the message was missed. If another civilization arises 100 million years from now, our signals will have long since faded into static. They will look at our sun and see just another yellow dwarf star, with no hint that we ever loved, fought, or dreamed here. This perspective that we are separated by time is perhaps more melancholic than the idea that we are alone. It means the galaxy is a ghost town. It is full of ruins, full of echoes, full of missed connections. We try to fight this fading. We send messages that are designed to last. In 1974, we sent the Arecibo message. It was a powerful, focused radio beam aimed at the globular star cluster M13, which is 25,000 light-years away. It contains a simple picture, numbers, DNA, a stick figure of a human, the solar system, and the telescope itself. It was a shout. But it will take 25,000 years to get there. If anyone replies, the answer will arrive in 50,000 years. Will humans even exist then? Will we remember we sent it? And then there are the Voyagers. Voyager 1 and Voyager 2, launched in 1977, are the most distant human-made objects in existence. They have left the solar system. They are in interstellar space. They are dead silent now, their batteries fading, but they carry cargo. The golden records. These are 12-inch gold-plated copper phonograph records. They are time capsules. They contain sounds of earth, wind, thunder, birds, whales, a baby crying, a kiss. They contain greetings in 55 languages. They contain music, Bach, Mozart, Chuck Berry, Blind Willie Johnson. They contain diagrams of how to play the record and where Earth is located relative to pulsars. The Voyagers are built to last in the vacuum of space, with no erosion, no rust, no air. They will last for billions of years. They will outlast for pyramids. They will outlast the continents. They will likely outlast the sun itself, long after Earth has been swallowed by the dying sun, long after humanity is a forgotten memory. These two small metal discs will still be drifting through the dark, carrying the sound of a kiss. They are messages in a bottle thrown into the biggest ocean of all. The odds of them being found are statistically zero. Space is too big. The probes are too small, but the act of sending them matters. It is a declaration of existence. It says, we were here, we felt things, we made music. But let's go back to the radio bubble, the sphere that is expanding at the speed of light. There is a fascinating thought experiment. If you were an alien astronomer 65 million light-years away, and you had a telescope powerful enough to see the surface of Earth, which is physically impossible. But let's pretend, what would you see? You wouldn't see humans. You wouldn't see the Great Wall of China. You would see the light that left Earth 65 million years ago. You would see dinosaurs. You would see the Chicxulub asteroid hitting the Yucatan Peninsula. You would be watching our past as your present. This means that our history is not gone. It is streaming away from us. The light from the campfire of Homo erectus is still traveling. The light from the construction of the pyramids is still traveling. The radio waves from the first broadcast of War of the Worlds are still traveling. The universe preserves everything, but it dilutes it. If we look at the universe through this lens, the silence takes on a different quality. It's not empty, it's just delayed. Maybe the galaxy is buzzing with life, but the signals haven't reached us yet. Or maybe they reached us 1 billion years ago, and we weren't ready. But there is a darker interpretation of the fading bubble, the dark forest theory, popularized by Lucasin's sci-fi novels. This ties back to the filter being ahead of us. The theory suggests that the reason the universe is silent is because broadcasting is suicide. Any civilization that reveals its location is immediately destroyed by a more advanced predator. The loud civilizations get wiped out. The quiet ones survive. If this is true, our radio bubble is a beacon of death. We are like a baby crying in a forest full of wolves. We are broadcasting our coordinates to anyone who is listening. We sent maps on the Voyagers. We sent the Arecibo message. We are shouting, "Here is fresh meat. Here is a habitable planet. Here are resources." Stephen Hawking warned about this. He said, meeting an advanced civilization could be like Native Americans encountering Columbus. That didn't turn out so well. In this scenario, the Great Filter is not a natural hurdle. It is an active purge. We haven't hit the filter yet because our bubble is still small. It has only reached a few thousand stars. Maybe the wolves are 500 light years away. They haven't heard us yet, but the signal is on its way. This makes the silence terrifying. It means the silence is camouflage. However, most astrobiologists lean toward the loneliness in time or rarity of intelligence explanations rather than the cosmic predator. The energy required to destroy a planet across interstellar distances is immense. Is it worth it just to swat a fly? Let's look at the durability of our signal. The radio waves will eventually become indistinguishable from the background noise of the Big Bang. This is called attenuation. Information becomes entropy. Order becomes chaos. This is the second law of thermodynamics applied to communication. Ultimately, our voice will be lost. But there is a type of signal that doesn't fade as easily. A technosignature that is physical. If we don't find radio waves, maybe we should look for Dysonian artifacts. If a civilization survives the filter, it will need energy. It might build a Dyson sphere, a shell of solar collectors around its star. This would block the visible light of the star, but radiate infrared heat. We have scanned the sky for these infrared excesses. We have looked at millions of galaxies via the WISE satellite, and we have found nothing conclusive. No obvious Dyson spheres. No Type 3 civilizations harnessing whole galaxies. This suggests that even the super civilizations are rare or non-existent. The filter is extremely efficient. It stops almost everyone. So, we are back to us. The little bubble of noise on the edge of the Orion arm. We are the anomaly. This realization that we might be the only ones currently on air creates a strange feeling of responsibility. We are the DJs of the galaxy. We are the only ones playing music. If we stop, the station goes dead. There is a concept called Lindy's Law. It applies to things that don't have a natural lifespan, like ideas or technologies. It says that the future life expectancy of a non-perishable thing is proportional to its current age. If a book has been in print for 50 years, it will likely be in print for another 50. If a civilization has lasted 100 years, it will likely last another 100. This is scary. We have been a radio-capable civilization for only 100 years. Lindy's law suggests we are fragile. We are in the infant mortality phase of technological life. Most civilizations might die in this cradle, but we can defy the odds. We are stubborn. Think about the Voyager probe again. It is currently about 24 billion kilometers away. It takes light and radio about 22 hours to travel from Voyager to Earth. It is in the interstellar medium, the space between stars. It detects the density of plasma. It hears the hum of the galaxy, a persistent vibration of ionized gas. Voyager has crossed the heliopause, the boundary where the sun's wind stops and the interstellar wind begins. It has left the bubble of our sun's protection. It is out in the open ocean. It is a tiny, fragile machine, built with 1970s technology. It has less computing power than a key fob. Yet it persists. It keeps calling home. I am still here. I am still functioning. This is a metaphor for humanity. We are small. We are fragile. We are surrounded by a cold, dark, silent void that seems indifferent to us. Our signals are fading. Our time might be short. But we keep sending. We keep exploring. We keep listening. The bubble is vanishing, yes. But it hasn't vanished yet. And maybe, just maybe, someone is listening. Maybe they are watching our bubble expand with the same mixture of hope and fear that we feel when we look at the stars. Maybe they are rooting for us. Come on, they might be whispering. Don't blow yourselves up. Don't destroy your biosphere. Make it past the filter. Join us. Or maybe there is no one. Maybe the silence is just silence. If that is true, then our bubble is even more important. It is the only place in the universe where the laws of physics have woken up and started to call themselves names. It is the only place where there is love, or music, or curiosity. We are the universe's way of being loud. As you lie in the dark, think about that radio wave leaving Earth right now. Maybe it's a snippet of a song, or a news report, or a late-night talk show. It shoots up from a tower, punches through the clouds, pierces the ionosphere, and races out past the moon, past Mars, past Neptune. It enters the dark. It becomes a ripple in the electromagnetic field, expanding forever. Even if humanity ends tomorrow, that ripple will keep going. It will travel for eternity. In 1 billion years, it will cross a galaxy that looks different than it does today. It is a permanent mark. We have spoken. We have broken the silence. And that cannot be undone. But the fear of the filter, the fear that we are walking into a trap, is still there. We have looked at the past, abiogenesis, the present, the radio bubble, and the neighbors, Mars. Now, we must look at the final implication. If we are alone, what does that mean for us? Is loneliness a curse, or is it a gift? We are going to the final chapter. We are going to look at the responsibility of being the last sentinels. We are going to turn the terror of the great silence into a promise. We are going to find comfort in the fact that there is no one coming to save us, which means we are the ones we have been waiting for. We are going to the lighthouse at the end of the world. The night is deep now. The radio bubble has expanded a little further. The Voyager probe has drifted a few more kilometers into the dark, and we are still here, lying in the quiet, asking the question that started it all. Where is everybody? We have walked through the terrifying possibilities. We have considered that life is impossible to start, the rare Earth hypothesis. We have considered that intelligence is a biological fluke, the intelligence trap. We have considered that civilizations inevitably destroy themselves with nukes or AI, the doom filters. We have considered that they are hiding or sleeping in digital utopias, or dead, and all roads lead back to one overwhelming sensation: loneliness. The great silence feels heavy. It feels like abandonment. We want Star Wars. We want Star Trek. We want a galactic federation to swoop down and tell us that we are part of something bigger, that there are adults in the room who can fix our climate, cure our diseases, and stop our wars. We want to be the children of the galaxy. But the silence tells us that there are no adults. There is no federation. There is no one coming to save us. For many, this is a source of existential dread. It is cosmic horror. The idea that in a universe of 2 trillion galaxies, we are the only ones who can think, feel, and dream is terrifying. It makes us feel small. It makes us feel like an accident. But tonight, we are going to flip the script. We are going to look at this loneliness from a different angle. We are going to see it not as a curse, but as a gift, a terrifying, heavy, magnificent gift. Imagine a universe without us. Imagine the Milky Way galaxy without Earth. It would still be beautiful. The nebulae would still glow with pink and purple hydrogen gas. The stars would still be born in stellar nurseries and die in supernova explosions. Black holes would still spin. Comets would still trail tails of ice. But there would be no one to see it. Without consciousness, the universe is just physics. It is just matter and energy interacting according to blind laws. A sunset on Mars is just light scattering through dust. It is not beautiful until an eye sees it and a mind interprets it. A supernova is just a release of energy. It is not tragic or inspiring until a consciousness witnesses it. We are the meaning makers. We are the mechanism by which the universe feels itself. As the astronomer Carl Sagan said, we are a way for the cosmos to know itself. If we are truly alone, if we are the only technological civilization in the Milky Way, then we are not just inhabitants of this galaxy. We are its nervous system. We are its eyes and ears. We are its memory. This changes the stakes completely. If there are a million other civilizations, then Earth is just one data point. If we blow ourselves up, it's a tragedy. But the galaxy moves on. Someone else will discover calculus. Someone else will write poetry. Someone else will explore the stars. But if we are the only ones, then our survival is not just about us. It is about the survival of consciousness itself. If we die, the galaxy goes blind. The lights go out. The universe returns to a state of dumb, unfeeling matter. The art, the music, the love, the curiosity, all of it vanishes forever. This realization transforms the great filter from a monster into a mission. It means that passing the filter is the most important thing that has ever happened in the history of the universe. We are carrying a flame through a hurricane. It is flickering. It is fragile. But it is the only light there is. We are the last sentinels. Or perhaps the first sentinels. Consider the timeline again. The universe is 13.8 billion years old. That sounds old, but stars will continue to burn for another 100 trillion years. We are actually at the very beginning of the stellar era. We are the early birds. Most of the planets that will ever exist haven't been born yet. Most of the life that will ever exist hasn't evolved yet. If we survive, if we spread to the stars, we could be the ancestors of a galactic civilization that lasts for eons. We could be the progenitors that sci-fi stories talk about. The silence isn't an empty room. It is a blank canvas. It is waiting for us to paint on it. This perspective shifts our view of our current problems. Climate change, nuclear war, AI alignment. These aren't just political or technical issues. They are existential tests. They are the final exams of the great filter. If we solve climate change, we prove that a technological species can live in balance with its biosphere. We clear a rung on the ladder. If we avoid nuclear war, we prove that intelligence can master aggression. We clear another rung. If we build safe AI, we prove that a mind can create something greater than itself without being destroyed by it. Every time we choose cooperation over conflict, every time we choose sustainability over consumption, we are pushing back the filter. We are widening the bottleneck. We are keeping the door open for the future. And we are doing it. It is easy to be cynical, but look at what we have achieved. We have international treaties banning CFCs to save the ozone layer. We have treaties banning biological weapons. We have the United Nations. We have the ISS, where Russians and Americans and Europeans and Japanese live together in a tin can, floating in the void, relying on each other for air. The ISS is a microcosm of Earth. It is a fragile bubble of life in a hostile vacuum, and it works. It proves we can work together. There is a concept in ethics called long-termism. It suggests that the lives of future people, the trillions of humans who haven't been born yet, matter just as much as our lives. If we survive the next few centuries and eventually colonize the galaxy, there could be 10 to the power of 52 future human lives, a number so big it dwarfs the number of stars. By protecting Earth today, we are protecting them. We are the guardians of their potential. We are the bridge between the primal past and the cosmic future. This responsibility is heavy, yes, but it is also ennobling. It gives purpose to our struggles. It means that your life matters, not just to you or your family, but to the galaxy. Every act of kindness, every moment of learning, every step toward wisdom is a contribution to the survival of the species. So let's return to the bedroom. Let's return to the quiet of the night. You're lying on a mattress covered in blankets. Outside, the wind is blowing. Above the roof, the stars are burning in the cold vacuum. The nearest star is 4 years away. The nearest galaxy is 2 million years away. The silence is absolute, but inside your head, there is a universe. There are memories of summer days. There is the smell of rain. There is the sound of a loved one's voice. There is the knowledge of dinosaurs and atoms and black holes. That internal universe is the most complex, precious, and rare thing in existence. It is a miracle of thermodynamics. It is stardust that has learned to think. The great silence is not a void. It is a space for you. If the universe is a dark forest, we are the only campfire. We don't need to be afraid of the dark. We just need to keep the fire burning. We need to add logs to it. Knowledge, art, science, empathy. We need to shelter it from the wind, and maybe, one day, far in the future, our fire will be big enough to be seen. Maybe another civilization, evolving on a wet rock a billion years from now, will point their telescopes at the Milky Way and see a strange, unnatural glow. They won't see a Dyson sphere. They won't see a weapon. They will see a beacon. They will see us. And they will know that the filter can be passed. They will know that they are not alone. But for now, the job is simple. The job is to rest. Even sentinels need to sleep. Even guardians need to recharge. The biological machine that carries your consciousness, your body, needs to enter its repair cycle. The brain needs to wash itself. The cells need to divide. You can let go of the weight of the galaxy. The Earth will carry you until morning. The sun will rise, just as it has for 4.5 billion years. The cycle will continue. You have faced the silence, and you have found your place in it. You are not lost. You are exactly where you're supposed to be, on the frontier of life, holding the line. Let your breathing slow down, in and out. The air you breathe is shared by 8 billion other humans, and trillions of other creatures, all clinging to this same rock. You are part of the team. Let the darkness wrap around you like a blanket. It is night empty. It is full of potential. It is full of tomorrow. The stars are watching. The future is waiting. Sleep well, and good night.